All right, number one, water is pumped into a tank at a rate modeled by WT equals 2000 e to the negative t squared over 20 liters per hour. So this is pumped into a tank. And that's a rate where t is measured in hours. Water is removed from the tank at a rate modeled by R of t. Here's R of t up here. And that is also in liters per hour, where R is differentiable and decreasing. Yeah, it does look like it's decreasing. Selected values of R of t are shown in the table above. Yep, thanks. At time t equals 0, there are 5,000 liters of water in the tank. Estimate R prime of 2. Show your work that leads to your answer. Indicate units of measure. All right, well, R prime of 2 is right here. It's between these two guys. So the way we would estimate R prime of 2 would be just to find the slope between those 2 points. So we would say R prime of 2 is roughly equal to, let's see, that minus that, 950 minus 1190 over 3 minus 1. I don't know what that works out to. That's 2. That's some sort of number that's negative. Is that negative 240? And let's see, indicate units. So it's in liters per hour. Show your work. There's me showing my work. Indicate units, indicate units. All right. So I think I got the numbers right there. I think someone would let me know if I got the numbers wrong, I hope. All right, B, not A2. Use a left Riemann sum. All right, so left Riemann sum. So we're going rectangles, but we're going up from the left side with 4 subintervals. So 1, 2, 3. It's amazing how that works out. 4 perfectly. By the table to estimate the total amount of water removed, because this is R for removed from the tank during the 8 hours. Is this an overestimate or an underestimate of the total amount of water removed? Give a reason for your answer. All right, so 2 things we want to do. First, we want to approximate the sum. All right, so the total water removed, we could say the integral from 0 to 8 of R of t dt is approximately equal to, let's see, the left-hand side here would be, this would be our height. So it'd be 1340 times the width here, which is 1. Plus, now if we're going from 1 to 3, the height here is 1190. And the difference between 1 and 3 is 2. Plus, let's see, between these two, we're going with the left side. So that's 950 times the difference between 3 and 6, which is 3. All right, and then between these two, let's see, there's the height, 740. And the difference between 6 and 8 is 2. And then we just want to work that out. Gosh, I don't know what 13.4, was this non-calculator? I thought this was non-calculator, so that'd be 22, 23, 80, 27 plus 150, that's 2850. That's 1480. And that equals, it was 8,000 and something. Was it 8,050 liters? It is calculator section? Gosh, I hope so. It's going to be for the next one for sure. So 8,050 liters. And then we have to say, is this an overestimate or an underestimate? So remember, we had a decreasing function. So our function was coming down basically. All right, so if we're doing left-hand rectangles from the left side over, it's always going to be extra area. So like all this is extra, all this is extra, all this is extra, all this is extra. So this would be an overestimate. All right, since R of t is decreasing. All right, and since we use left-hand rectangles, if you want, you could, there's a little arrow. Yeah. All right, next one, part C. Use your answer from part B to find an estimate for the total amount of water in the tank to the nearest liter. All right, so we don't have to do 3 decimal places, nearest liter, at the end of 8 hours. All right, so let's see. We have a certain amount of water in the tank to start. So we have 50,000 in the tank to start. We just figured out how much was being removed, which was 8,050. Plus we have water that's being added, this guy. So in order to find out how much is added, we would integrate from 0 to 8 of W of t dt. I'm assuming W is for water. So we know that W is 2000 e, 2000, not 100, e to the negative t squared over 20, which is not something we can integrate nicely. We definitely have to use our calculator to do that. All right, so where is our trusty friend here? There he is. So let's see, math 9, nope, yes, math 9 is integral. We're going from 0 to 8, and our function is 2000 e raised to the negative variable squared over 20. All right, and d, whatever our variable was, we used x here. So that's 7,836. All right, so we're just now adding that stuff up, adding and subtracting, I guess. So we got 50,000 plus, let's see, this last answer we got minus the 8,050 that we got from the previous one. That was the water was draining out of the tank. And we get 49,786. And that is in liters. Let's see, did they ask us for use your answer from B to estimate? This is an estimate. Total amount of water, so maybe we should put the roughly equal to, there we go, to the nearest liter, so nearest whole number here at the end of 8 hours. 8 hours, yep. Part D, for 0 to 8, is there a time t where the rate at which the water is pumped into the tank is the same as the rate at which the water is removed from the tank? Explain why or why not. Ooh, this strikes me as some sort of intermediate value theorem. So we want the two rates to be equal. So we want to know, does R of t equal W of t? That's what we want to know. All right, well, if they are equal to each other, we would need them to equal 0 at some point in the interval from 0 to 8. All right, so what we should probably do is check the two endpoints and see what's going on there. Maybe it's positive at one and negative at the other, in which case, since they were already told us that it was differentiable and that this is differentiable, we get that it's continuous. So this is a continuous function. And if it's continuous and it's positive at one place and negative at the other place, then it must equal 0 somewhere by the intermediate value theorem. So let's just try the endpoints. What's R of 0 minus W of 0 equal to? And what's R of 8 minus W of 8 equal to? Well, R of 0 is 1340. All right, and R of 8 is 700. And let's see what happens at these other 2 points. So we've got to plug into our function, this guy. So that'd be 2000. Well, 0 is not so hard. If we plug in 0, we get 0 up here. E to the 0 is 1. We get 2000, which is going to be negative. It's less than 0. That's all we need to know. I don't actually need to know the value. I just need to know what sign it is. All right. And then for the other one, we're plugging in 8. So then we've got second e to the negative 8 squared, which is 64, divided by 20, 81.5. Which 700 minus that is definitely going to be greater than 0. All right, so by the intermediate value theorem, R of t minus W of t equals 0 for 0 is less than t is less than 8, somewhere between them, not at the endpoints, because we already checked the endpoints, it's not 0 there. Therefore, R of t equals W t for 0 is less than t is less than 8. Check. Done. All right, so we did have to say it was a continuous function, and then we can say by the intermediate value theorem, it's done because we had positive at one spot, negative at one spot. So it was negative here, positive there. We could also do the functions the other way around, which honestly might make more sense, W minus R, since W is being added and R is being subtracted, but it didn't make a difference really. All right, so here's our answers. We were doing r prime there, weren't we? Ah, shucks. So I left off the r squared. Oh, yeah, squared. It is an acceleration because r was already a rate. Well, shucks. So there was -1 there for units, but we got the right estimate. So there we go. R squared. We got the right answer there. We had the work there. And we said that it was an overestimate since the function was decreasing. So we got all 3 points there. We got 1 there. Let's see, we wrote that out and we got that answer. So we got this and that. Yep. Let's see, they did it the other way around, but it looks like they've got the same thing. Positive, negative, continuous, intermediate value theorem. And we get that it equals, they're equal to each other. So considers that function or the other way around. So we did that. Answer with explanation, we did that. So we got this, we got that. So I would have gotten 8 out of 9 on that one. Oh darn. Units. All right, next one here. So the figure above shows the graph of the piecewise linear function f between -4 and 12. The function g is defined by it's the integral from 2 to x of f of t dt. So we're starting at 2 basically, and then integrating this function. So that kind of means that the derivative of g is the function f. So does g have a relative minimum, a relative maximum, or neither at x equals 10? Justify your answer. So in order to find where g has relative mins and maxes, we need to find its derivative. So g prime is, well, if we take the derivative of the integral, we just end up plugging the x back in. If this was like x squared, then we'd be plugging in x squared to have it times 2x and do a chain rule. But since it's just x, we just get f of x. So now we want to know, well, we're trying to find mins and maxes, so we set it equal to 0. So when we set it equal to 0, we get it's 0 there, it's 0 there, it's 0 there, and it's 0 there. So we get x equals -2, 2, 6, and 10. Those are our critical points. T is between W. For D in the first one, we can also say that there may meet since R of T is between. Yeah, that would work. That boils down to the same thing. All right, so now let's keep looking at the side now. We'll do our number line chart. So we're starting at -4. And we're ending at 12. And let's see, we've got -2 on there. We've got 2 on there. We've got 6 on there. And we've got 10 on there. So let's see, we're negative here. Then we're positive. Then we're positive again. Then we're negative. Then we're negative again. So that means g of x would be decreasing, increasing, increasing, decreasing, decreasing. So we get right here, we have a relative min. This would just be something that probably look like this. It would keep going up. This would be a relative max. This would be decreasing and then decreasing some more. So not a relative min here. So then the question asks specifically about x equals 10. So it's neither. So at x equals 10, g of x has neither a relative min or relative max, since it is decreasing on both sides of 10. Or you can just say since it's decreasing there, that'd probably work. Part B, does the graph of g have a point of inflection at x equals 4? Justify your answer. All right, so point of inflection. Let's see. I know I'm going to get blocked by the picture up there. So point of inflection, we need to look at the second derivative. Well, we've got the first derivative. G is just g prime is f of x. So that means g double prime is f prime of x. So f prime, we can get whether it's positive or negative by where it's increasing and decreasing. All right, so that means if we want to look at the sign of g prime between -4 and 10, let's see, we change from increasing to decreasing here, which is at 0. We change from increasing to decreasing here at 2. We change again at 4. And then we change again at 8. And then, oops, I was supposed to go to 12 here, wasn't I? 12. So let's see, we start off that this function is increasing. So that means G double prime will be positive. Then we're decreasing. Then we're increasing. Then we're decreasing. Then we are increasing. And then we are decreasing. So that means G of X will be concave up, concave down, concave up, concave down, concave up, concave down. So we're asking specifically at X equals 4. Well, 4 is right here. So yes, we have a point of inflection. So G of X has a point of inflection at X equals 4. Since G double prime changes sign, there, or you could say G changes from concave up from concave down. Or we could say F changes from increasing to decreasing. Yeah, it's fine. Even if the function F is even if it's undefined there, it would still, because the function G is going to be a continuous function. Right? And that's what we care about, is G continuous. We don't care about G double prime having a non-continuous point. All right, the corner there, yeah. All right, let's move on to part C now. So find the absolute minimum value of the absolute maximum value of the function G on the interval from -4 to 12. Justify your answer. All right, so whenever we're asked to do absolutes, we have to do a candidate test. So we need our candidates, which would be X values, and we need to know what's going to be the value of G there, which remember is the integral from 2 to X of f of t dt. So our candidates are, well, it's the endpoints, and it's also all the zeros we got. So if we go back here, all these zeros, so -2, 2, 6, and 10. Boy, that's a lot of candidates. All right, so let's just start trying some. There's probably some that we could eliminate right away, like probably 2, but whatever. 2 is just going to be 0 because we're going from 2 to 2. So. Done. G of -4 is, let's see, that's the integral from 2 to -4 of f of t dt, which is negative. We want to turn it around, so it'd be the integral from 4 to 2 of f of t dt. And now if we're going from -4 to 2, let's see, this area is negative, this area is positive, it's the same shape, those will cancel out. And then we've got this guy here, which is 2 by 4. So 1/2, 2 times 4 is 4. Next, we're going from the integral G of 12 is for the 2 to 12 of f of t dt. So we don't have to turn that one around. It's already going the right way. So we have this triangle and this triangle, which each one of these triangles is a 4. And then we have this one and this one, which are -4s, and then another -4. So that one's going to end up being -4. All right. For -2, we're going from here backwards. So G of -2 equals the integral from 2 to -2 of f of t dt, which we have to turn around if we need to do the area trick. So it'd be negative the integral from -2 to 2 of f of t dt. So now if we're just going from here to here, this is 4, so that's 8, but then we have this negative sign. So we get -8. Did I forget about the negative sign on that one, or did I do the negative sign on that one? I think I forgot about the negative sign that one. I'm assuming one of you would have told me, but yeah. Looks like we get -8 there. For 6, let's see, we're going from 2 to 6 of f of t dt. So let's see, we're adding 4 and 4, so that's just +8. That looks like a good candidate right there. And G of 10, we got 4, 4, and then -4, -4. That's 0. So it looks like right here is our absolute max at 8. And right here, this -8 seems to be our absolute min. And justifying our answer is the candidate test. All right, next one, part D. Find all intervals for which g of x is less than 0. All right, well, at 2, we're at 0. And as we start going backwards, we become negative because this area is negative and it stays negative. So we'd be negative for here, here, and here. So from -4 to 2, it's definitely less than 0. All right, because those integrals are negative, and we can look at that here, like -4, we got -4, -2, we got -8. If we did -4, well, we already did that. And at 2, we were 0, and we want less than or equal to 0. So all this section from here to here, it's going to be negative. Then when we come this way, we get positive here. So we're positive here. Then when we get to here, we start taking away, and we get to 0 once again when we hit 10. So starting at 10 again, we're less than 0. And all this down here is negative area all the way up to 12. So that would also be 0. Or negative, I guess. All right, let's see what we have for answers here. The function g has neither a relative min nor a relative max. Since g prime equals f, which we said f is less than 0, so it was just negative on both sides. That works. The graph of g has a point of inflection at 4. Since g prime equals f is increasing and decreasing. Okay, that works. Increasing on one side, decreasing the other, or concave up and concave down for g. So answer with justification, point there. Answer with justification, point there. 4 points here. Let's see. G prime equals f. It changes sign at -2 and 6. So we didn't actually need to check all those other ones. We just needed the endpoints and where it changed sign, not just where it equaled 0. But we had all those, so we considered those two and we considered those two. So that's 2 points for that. Answer with justification. The absolute minimum is at -8, or is -8. The absolute maximum is 8. That's what we want, the actual values. There it is. All right, so we have that. That would be our 2 points there, one for each of those. And g prime is less, or g of x is less than 0 from -4 to 2. So in other words, -4 to 2, and then from 10 to 12. Including the endpoints like that. We had both intervals, so that's 2 points there. Full credit. Yay. Got it all. Woohoo. All right. So there was our free response for this week. Let's go check out the multiple choice. All right. So I was starting to look at some of these. Looks like the alternating series ones were the troublesome ones. A lot of them you did pretty well, like the ratio test here did pretty well. Let's look at this guy. All right, so we're looking for the alternating series error bound. So we've got this series. It's alternating because we have this -1 to the n plus 1 here, which means it goes negative, positive, negative, positive. The rest of this is always greater than 0, and it's always decreasing. So it's definitely an alternating series. All right, so S sub k is the partial sum, so it's the sum only to k. All right. What is the least value of k for which the alternating series error bound guarantees that the difference between the actual sum and the partial sum is less than or equal to 0.0005? All right, so what we need to do is, well, we need to remember what the formula is for the error bound. So this error bound is just the next term. So that would be 1 over the absolute value of the next term, by the way, k plus 1, 2 to the k plus 1. We need that to be less than or equal to 0.005. There's another 0 in there. There we go. All right, so it's just a matter of solving this. So we multiply this up and divide this over, or we could just graph them and see where they cross. 1 over 0.0005 needs to be less than or equal to k plus 1 times 2 to the k plus 1. All right, we could just plug in these answers if we want. We could type this out. This is definitely a calculator problem. What's 1 divided by, I said on, 1 divided by 0.0005, 2,000. So we want this to be 2,000 or more. And we can just plug in the numbers till we get there. So let's see. I think it started at 6. All right, so if we do 6 plus 1 is 7 times 2 to the 7th. Not there yet. 8 times 2 to the 8th. This should get us there, I think. There we go. So k plus 1 is 8, so that means k is 7. There's our guy right there. All right, so if we add up the first 7 terms of this, it will be within 0.0005 of what the actual total sum would be. All right, next one. So we did okay on that one. So now we got 5 wrong here. Which of the following series can be used with the comparison test to determine whether this series converges or diverges? Well, just looking at this, I know that this series is roughly the same as 1 over n, which is going to diverge. That would be a limit comparison test, though. We want to do just a straight up comparison test. All right, so what I want to do then is just kind of look at what's here. So what's here would be 2 over n if we simplified. And then we're always adding 5 to the top. So that means this guy is always going to be bigger than that guy, which is what we want. We want something that's smaller than this guy, but that will still diverge. And this definitely diverges. So that the sum of that diverges. It's just, times a 2 here. Right? So 5 plus 2n over n squared is always going to be greater than or equal to 2 over n because it's got this extra plus 5 on the top. All right? Otherwise, they're basically the same. Right? Or you can think of this as like 5 over n squared plus 2n over n squared. And that's 5 over n squared plus 2 over n, which is always going to be greater than 2 over n for any of our n values from 1 on down. All right, so we want to compare it to 2 over n, which is this guy right here. We don't want to use that because it's not the right power of x. We don't want to use that because 5 will actually make that bigger for some points, and we want it to always be smaller. And this guy is always going to be smaller, and this guy actually converges. We don't want that at all. It's going to converge. That doesn't tell us anything. We want something that's smaller than our guy that will diverge because we know this guy is going to diverge. All right, moving on to the next one here. For what values of p will this series converge? So the first thing that jumps out at me is this tells us that it's an alternating series. That means as long as the limit as n goes to infinity of 1 over n to the p equals 0, then it will converge, right, for the alternating series test. And I mean, the rest of it is this is positive and it's decreasing, but that's not a big deal right now. We know that's true. All right, so we just want to know for what values of p will this equal 0? Well, no, we definitely need positive values of p. If it's negative p, that's not going to work. Greater than 1, that does work, but it says only, and like we could have 1/2 here and it would still go to 0. In fact, any p value greater than 0 is going to work. Less than 0 is not going to work. That's actually where it's going to diverge. It's less than 0. So there's our guy. Half of you got it, looks like. One person didn't answer it. Moving on to the next one. All right, these are good practice problems. We definitely need some review on series, sequence, and series stuff. All right, which of the following conditions is necessary to conclude that this series converges using the alternating series test? All right, so alternating series test, 1, we need that it is an alternating series. 2, we need that it's always decreasing after a certain point. And 3, we need that the limit as n goes to infinity of whatever that inside is goes to 0. So that's what we need for alternating series test. So let's see, the terms alternate signs after some n. So at some point it's alternating. Yeah, we need that. The limit goes to 0. Yeah, we need that. A sub n plus 1 is less than or equal to the absolute value of a sub n. So it's basically saying that it's decreasing, like we want for some integer. So at some point it starts decreasing and then decreases forever. Yeah, we need all 3 of those for alternating series test, and that's why the answer is D there. All 3, not just that it's decreasing in the limit. Yeah, they kind of Looks like for you were just like, oh, well, duh, it's alternating. Well, you actually have to have that as one of the conditions. And on to the next one, maybe, if it lets me. All right, the alternating series test can be used to check for convergence for which of the following? Well, just looking at this, it's switching back and forth between these two functions. That's not always going to be decreasing. All right, so 3 is out right away because it's these two functions are different functions. It's not going to be decreasing always, so that doesn't work. This guy, let's see, the limit goes to 0. It's alternating, it's decreasing. So this guy looks like he's going to work. This guy, let's see, he's alternating. Ooh, but if we take the limit here, as n goes to infinity, it's the same power on top and bottom. We're going to get 1 over 100. That's not 0. So this is not going to converge. It's actually going to diverge. So, and this says check for convergence. So the only one that's we can use the alternating series for convergence is number 1. Sneaky. Wish this web page would work a little faster. All right, next up, which of the following statements is true about the series with positive terms if the limit of that equals L? All right, well, if it says it's positive terms, this is exactly the ratio test. Like, remember the ratio test is this, but if it's positive terms, then we don't need the absolute value. It doesn't matter. So L is going to be greater than 0. So the ratio test tells us that if this L is less than 1, it will converge. If this L is greater than 1, it will diverge. And if L equals 1, we got to use some sort of other test. All right, so we want converges for L less than 1. That's less than 1. That's true. Converges for L equals 1. That's not necessarily true. It might not. Converges for L equal 2. No, we want it decreasing. We want it getting smaller. So no, that's actually going to diverge, not converge. Converges as L goes to infinity. Nope, that's also not true. That would make it diverge. All right, so the one that's true here is A. Moving on to the next one. Oh, we did pretty well on this one. Shown to converge by the ratio test. 7 of you got that. Only one person missed it. Let's go to the next one, if it'll let me. No, there we go. 5 wrong. Which of the following series converge? All right, well, this looks like a bunch of ratio tests to me. Yeah, exactly right. All right, so for the first one, I would say this is the limit as n goes to infinity of this guy with n plus 1 over this guy to the n. All right, and technically it's absolute values, but the absolute values aren't going to matter. So we're going to get n plus 1 over n times, let's see, this is going to cancel out completely. And we've got one of those left. 1 over e is what's left. It's on top. We can bring it down to the side here. As we take the limit of this goes to infinity, this is 1 over e. So this becomes 1 over e, which is less than 1. So this first guy converges. Good to know. The second guy here, let's try that one. Limit as n goes to infinity of n plus 1 factorial over 100 to the n plus 1 times, and we flip it over. Remember, we divide, so we flip it over. 100 to the n factorial. That's going to cancel out completely. That's going to cancel out completely. We're left with n plus 1, and we're left with one of these 100s. So n plus 1 over 100 goes to infinity, which is bigger than 1. So the second guy here diverges. And now we try this last one here, kind of the ugliest looking one of them. So we've got n plus 1 factorial squared. Gosh, that's nasty. 2n plus 1, so 2 times n plus 1 would be n, 2n plus 2 factorial, times this guy flipped, 2n factorial over n factorial squared, Technically, this is an absolute value, but they're all positive, so we don't necessarily need that. So with this guy and this guy, we're going to get these two extra terms. So this is going to be 2n plus 2, 2n plus 1, and then it'd be 2n factorial, which will cancel out with that. Between this one and this one, so this would be n factorial and then another n factorial. This would be n plus 1 factorial and then another n plus 1 factorial. So these guys are both going to cancel out, and the factorials will both cancel out and just leave us with n plus 1s here. So we get n plus 1 times n plus 1 on top. On the bottom, we've got 2n plus 2, 2n plus 1. So now if we just look at the highest power on top and bottom, this is going to be n squared. This is going to be 4n squared. So the limit's going to go to 1/4, which is less than 1. So that means this guy, as nasty as he is also going to converge. So it looks like 1 and 3 are going to converge. Is that an answer choice? Oh, there it is right there. 4, you got that. That was pretty good. That was a tough one. Yep. And yeah, lots of work to show on that one. Yeah. All right, moving on to the next one here. Maybe not. There we go. Ah, 6 people got this one right. Good job. Next one. Well, only one person missed it. Wonder what's happened to the other, 35 people in class. Converges conditionally. All right. That means it will converge, but if we get rid of the -1, it will diverge. All right, so if we get rid of the plus or minus, so first of all, we want things to converge. This guy is geometric, where r equals -3/2, which is greater than 1. That diverges just to begin with. So that's not even going to converge. This guy, he'll converge, and he doesn't even depend on the -1. So this guy's absolutely converges. Like if we get rid of the negative signs, it's still going to converge. This guy, let's see, he converges as is, but if we get rid of the -1, it's the sum of 1 over the square root of n, which I guess I should put an arrow there, not equals, which diverges. All right, so without the -1, it diverges, but this guy as it is converges. That's what we want. That's what conditionally means. And this guy is a geometric with r equals -1/5. And if we take the absolute value of that, that is less than 1. I suppose I should absolute value here too. So this guy converges absolutely. All right, so the one that we want here is C. That's our guy. Conditional convergence. Looks like we did okay there. Absolute convergence is easier. That's true. We just get rid of the negative signs and see if it still converges. Most of you got that. Yep, still C. Yep. Oh, I had some issues here. If the partial sum of 3 terms is used to approximate the value of the convergence series, blah, 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 what is the alternating series error bound? Which is going to be the 4th term. All right, so if we did 3 terms, the error bound is the absolute value of a sub 4, the 4th term. But the 4th term, it starts at 3. So, so that means we'd have 3, 4, and 5 are our 3 terms. The error bound would be the 6th term. So we're going to plug in 6. So it's going to be a sub 6 and the absolute value of that. So we get -1 to the 6 plus 1, 6 over 2 to the 6th. Now that's going to just disappear because we're in absolute value. And then we have 6 over 2 to the 6th. 2 to the 6th is what, 64? Yeah, 2 to the 5th is 32. Each of those is divisible by 2. 3 over 32. There it is right there. Sneaky. And you get that if you have the -1 and the 6 and add them together. Oh, that's sad. All right. I guess you get that if you just plug in 3, which, yeah, that's not unheard of. Or plug in 4 maybe. All right. This one, let's see. We've got n values. We got partial sums. The alternating series converges to S, so it is going to converge. And terms are decreasing. That's what this is saying. It's decreasing. All right, for all k. The above table shows values of the partial sums for 4 values of n. Yeah, 1, 2, 3, 4. If S of 8 is used to approximate the sum S of the series, what is the alternating series error bound? Well, if we're using S of 8, the next term, so not the next sum, but the next term would be the error bound. So the difference in these two is going to be the error. All right, so the next term, a sub 9 in absolute value, is equal to S9 minus S8 in absolute value, the difference between the terms. So this is just going to be 0.459 minus 0.157, and the difference in those is 0.302. There it is. It's a sneaky problem. I like that one. And that's the last one. All right, so that's all of them. Cool.